So for our first example, we'll be using the inverse of Euclidean theorem. We have 5 mod 23. Firstly, this is the big number. This is the number that we want to get, and this is the one we're going to use to multiply it to get this one. Okay, so we do 23 equals 5 times what number gets closest before, not after, not bigger, smaller. We have 4, which is 20, remainder of 3. We get this number down, and we write it again. So it becomes 5 is equal to, then this number down here, which is 3, times what? It will be 1. Plus, we'll have a remainder of 2. Then we get this one down here again. So it's 3 is equal, we get this one as well. 2 times 1, then we have plus 1. For Euclidean theorem, whenever this is 1, we do not have to go further. So now we have these three equations. From these three, we will find the inverse of this. So what we will do, we'll make these three the subject of the equations, okay, instead of 23. So we move all this to the other side of the equation. So all this will become, we have 1, all this will become something like this. So it becomes 3 is equal to 23 minus 5 times 4. Then it becomes 2 is equal to 5 minus 3 times 1. Then it becomes 1 is equal to 3 minus 2 times 1. So as you can see, we have 3 here, and we have 3 here. We have 2 here, and we have 2 here as well. And we have the common of these 2 as well. Okay, so what we're going to do one by one, this is our first equation. This is our second equation. This is our third equation. Okay, firstly, we put this into here, then we put this into this, as well as this into 3. So we'll do this by steps one by one. So now what we'll do, we will have 3 put in here. This whole equation put in there. Okay, so we have 2 is equal to 5 minus 23 minus 5 times 4. Okay, so we have this here. Okay, because it's times 1, so it won't change a thing, so we write the same one. So this would become 5 minus 23 plus, because this negative goes inside here and inside there as well. So 5 times 4. In this case, we have 5 times 4, and we have 5, this, for example, this is times 1. So basically this becomes 5 times 5 minus 23. So this is the equation that we're going to use again, right? So we're going to remove all of this, okay? So now this one will become 5 times that. Okay, so next what we'll do is we'll come here. We have our 2 is equal to 5 times 5 minus 23. This is our new equation. We input this into our 3, which was what? It was 23. This was 1 is equal to 3 minus 2 times 1. Okay, and of course we need our original 3 equation from up top, which was 3 is equal to 23 minus 5 times 4. Okay, so we input this into here, and we also input this one into there. Alright, so now we will have 1 is equal to 23 minus 5 times 4 minus 5 times 5 plus, 5 times 5 plus 23. Okay, this is our final equation that we have. Okay, so now we have to simplify all of this, of course. So 23 and 23 becomes 23 times 2. Then we have minus 5 times 4 minus 5 times 5. These two are both common with each other, so we'll only add these two with each other. So it becomes this times this, okay, minus 5 which is both 5, times 9, which is the same as saying 20 and 25, although this comes 45. 5 times 9 is also 45. So now we can see that we have 23 times 2, because our original mod was 5 mod 23. Okay, this would also equal to, if we get rid of this one, equals to 1 mod 23. Alright, so we need anything to find the inverse of this one. So 23 times whatever we have, it will always equal to 0. So this one, we won't be needing it. We only need this part. So as we can see, we already have 5 here. So it's simple. What is this 5? We input it into here. Alright, but our 9 is negative. As we can see from the sign over here, it's a negative one. So it's negative 9 mod 23. Of course, we cannot have negative. So in this case, what happens is our minus will be 23 minus 9 is equal to 14. So this is our final answer. It's 14. 23 minus 9 equals 14. So 14 is the inverse of 5 mod 23. And that's how you solve it.